Hello, everybody. My name is Joseph Salazar with Technical Marketing at Ativo Networks. This is the second part of the Identity Security Bootcamp series called Disrupting the Attacker's Toolkit. As a reminder, this webinar uses the Threat Defend platform and its various components to illustrate concepts through quick demonstrations and walkthroughs. Please visit www.ativonetworks.com for further information on the products and topics covered here. So, a quick review. Part 1 focused on things an organization can do before an attack. This part covered visibility, attack surface reduction, and concealment. Now, Section 1 covered seeing what attackers can attack. Now, this section discussed reducing the identity and network attack surfaces. Section 2 discussed deploying defenses from the endpoints, Active Directory, on-premises networks, and the cloud using bait and concealment as preparation for your defenses. Part 2 is going to focus on things an organization can do during an attack. Now, this part covers detection, misinformation, misdirection, and engagement. Section 3 will discuss derailing attacks, and it will talk about protecting production credentials and data from discovery attempts while misinforming and misdirecting attackers away from the production assets. And Section 4 will talk about engaging attacks, and this will discuss using decoys to engage attackers, record activities, and capture forensic evidence. So let's go ahead and talk about the things to do during the attack. First up, derailing attacks. So if you recall, last week, we talked about preparing for your defenses and reducing your attack surface. Now, this is where all that preparation we discussed pays off. So let's start with the endpoints. First is misdirecting service discovery away from the production assets. Now, generally, attackers will run port scans to find open services to compromise. They do so that they can move laterally from system to system. It's one of the things that they do. This misdirection or deflection will redirect the recon activity to a black hole IP or a decoy if you chose to deploy enterprise decoys while generating an alert. So if the activity touches a decoy, the responses will trick the attackers into thinking they have access to the production system and interact with it. So this service misdirection that happens at the endpoint redirect that activity to a decoy and force the attacker to engage with it. After you misdirect or deflect that activity, we want to detect attempts to access those concealed assets that we configured in Section 2 of Part 1. So we should be getting alerts anytime the attackers attempt to access or enumerate these hidden production assets. Not only do we get an early alert, but we can also gather intelligence on their activities, because everything that's happening at the endpoint, it can get captured. And then afterwards, we want to initiate a response. Now, responses can vary from activating a partner integration. So if you have an integration with, say, a firewall or an EDR function, you can activate that. Or you can use native quarantine functions or anything else of the sort. So as long as this early response happens, it will limit the damage that the attackers can do, such as stopping a ransomware attack before it spreads. So think about it this way. As the attacker is attempting to move from that initially infected system, if you can quarantine it, so you get an example of a ransomware attack, then they can't move that ransomware to another system to infect or use that reconnaissance to find your high-value target for the ransomware to infect. And that's all the stuff that happens at the endpoint. So now let's discuss what happens on Active Directory. Now here, the first goal is to detect unauthorized Active Directory queries because it's the primary means for attackers to conduct reconnaissance, identify targets, steal credentials, and escalate privileges. Now, all of these are the mechanisms that they use to move laterally. Now, attackers will query Active Directory using native tools or applications like AdFind and Bloodhound to data mine the domain controllers for information. That information is what they can then use to progress or advance their attack. The key is that detecting and alerting on these queries during the discovery phase of the attack can limit what the attacker can accomplish. Well, while detecting these unauthorized queries will also hide those sensitive results that we concealed in phase 2. Now, these include privileged accounts, service accounts, domain controllers, and the like. These are all sensitive or privileged objects. Simultaneously, we will return decoy results from those AD's queries. This misinformation and concealment will deceive the attackers and misdirect them either to a black hole IP or decoys for engagement if you chose to deploy them as part of your initial defenses. So again, rather than going through a bunch of slides, let's go ahead and look at what this looks like. What I'm going to show you is how we configured all of those defenses in section 2. First off, what I forgot to show last week was the deflection configuration. Now, the way deflection works is that we can do both inbound and outbound redirection. So any inbound activity that touches a closed port or any outbound activity that touches a closed port, we can redirect. Now, for the purposes of this demo, I've set 2 inbound rules. One to redirect any web traffic or SSH inbound, and one to redirect SSH or web traffic outbound. Now, it doesn't matter if the system that is conducting that illicit activity has the protection or the destination has the deflection protection, it's going to work. So that is the deflection configuration. The AD Secure, as a reminder, I added a bunch of fake credentials, and remember I added these actors to the list. Very quick question, are there valid processes that can confuse by the deception technology? We discussed that early on. The key to this is that regular users will not be using these tactics that the attackers would use, right? They would be using command line access. They don't have access to the graphical user interface on a Windows box. And so these are the things that we look for, right? So a regular user will use the GUI, a attacker will use command line, and it's those command line tools and other things that we will redirect. For example, a regular user is not going to be using Bloodhound to enumerate Active Directory. Now, as a reminder, these are the actors that I created as a decoy results. And then again, we hid all of the privileged admin accounts and service accounts and some domain controllers. And then we did some data cloaking, right? So here we configured a bunch of hidden assets. So these are the assets that we are hiding at the endpoints. Notice here I've got a bunch of documents, and I've got a folder called Hide Me. And then I've got some shares that I'm hiding as well, and I'm adding fake shares in their place. So as a reminder, that is what we did to do the hiding. And so now I'm going to show you a side-by-side demo of what the attacker will actually see when they are conducting their attack. So on the left-hand side with the purple background, I have a system that is unprotected. On the right-hand side, with the teal background, I have a system that is protected. Notice here that I am logged in as the same user on both systems, right? We are the same user on the same Active Directory in the same subnet. You can tell by looking at the IP addresses, this one is 5.189 and this one is 5.130, right? Notice also that we are on the same domain, right? So here we have SE-demo local is the primary DNS suffix, and the so that is all part of the same DNS. So they're part of the same domain, part of the same network, part of the same Active Directory, and they are logged in as the exact same user. So what I'm going to do is I'm going to run a batch file that runs a bunch of commands that an attacker would normally run using native tools that are built into all Windows systems, right? And what we're going to see is the difference in the results. So the first attack, command that an attacker would normally run is nltest/dclist. nltest is a built-in utility within Windows, and the /dclist will list all of get a list of the domain controllers in the environment. So in this case, adscdemo.scdemo.local is the primary domain controller for this domain. Now, if I run the exact same command on the protected system, notice I get 2 different servers, one of which is a primary domain controller. Neither of one is the actual result. So this is marwinserver1.scdemo.local, which is the primary domain controller, and we have marwinserver2, which is a secondary domain controller. The /dsgetDC flag on the nltest list command gives you the specific domain controller you are connected to. In this case, this is the primary domain controller, and we should see the same information here on the protected system. Notice, though, that the result is consistent. It is still pointing to the decoy primary domain controller. So as an attacker, then I want to look for all of domain admins in the domain group that belong to the domain. This gives me an idea of who I can target for privilege escalation. So here you notice I've got a bunch of regular accounts. Remember those actors that I configured? Here they are. Clearly, Brad Pitt, Johnny Depp, and Tom Cruise do not work for TiVo Networks, but they are listed here as domain admins. Now, to verify that the users are real, I'm going to check a specific user account. In this case, I'm going to check Amy Gully. And notice I get information on Amy Gully. I get the last password set, the password expiration, the last logon, etc. Here, I'm going to check Brad Pitt. Notice I get the same type of information, but the data is different, even down to the fact that this Brad Pitt belongs to domain admins and domain users, but the Amy Gully account also belongs to backup operators, RDP groups, and IT level 2. So notice again, same type of information, different data. Now, the next thing I'm going to do is I'm going to look for service principal names. Service principal names are how the domain controller, Active Directory, tracks services which servers are authorized to authenticate with a service account. So the setSPN command does that. If you run it normally, it would just allow you to set the service principal name for a particular service. The -q means I am querying it. And in this case, the query is for HTTPS servers. So when I run that query, you notice I get a bunch. I get a code repo. I get some CRM information servers. I get an SAP web server. If I run that on the protected system, rather than getting the same information, I'm getting Marwin server 1. And I've got an HTTPS server. You see, notice that there is a restricted Kerberos host, etc. Now, just to show that these systems are live, I'm going to ping them on the protected system. And notice that Marwin server 1 responds with an IP address, and so does Marwin server 2. So these are actually decoys that are running in a decoy environment. Now, the klist command lists all Kerberos tickets that are currently in memory. Now, one of the things that we'll do here is we'll check to see if there is any information that doesn't look right, but it's also a way for us to identify and confirm information that we got from the domain controller when we were running our queries. So in this case, I run the klist command, and notice here that I'm getting the key distribution center, which should be the primary domain controller, and that matches, right? And I'm getting all of these Kerberos tickets that are currently in memory. I'm going to run the exact same command, and notice again, the KDC is the fake primary domain controller. So all of the information is consistent. Now, these are fake Kerberos tickets that are in memory. Now I'm going to run the netuse command. The reason I'm running the netuse command because I want to check to see what network drives are mapped. Notice here that I've got a file manager open, and here you see that I have the same share mapped to both drives. There's an X drive. So if I run the netuse command, it should show me the X drive. And in this case, on the unprotected system, I do get that X drive. When I run it on a protected system, I do not get an X drive. I get 2 fake shares. Now, these are decoys. Again, Marwin server 1 is a fake share, and so is this IP address. Now, these are decoys. So if the attacker attempts to do lateral share traversal, or I am running a ransomware attack and I'm trying to encrypt these shares, I'm going to end up on a decoy. I'm also going to check and show you something because this is important for the next part. So I'm going to see what services are open on these systems, right? So these are all the ports that are open. These are all the services that are available on the system. Now, these are all typical Windows ports, 135, 445, 3389, and then a bunch of ephemeral ports on the 4900 range. These are all normal use. Now that I've shown you some of how we misdirect, I'm going to show you hiding and denying access, right? So I'm going to go into the folder, and let me here open up another command line, because I want to show you what the attacker sees versus what a regular user sees. So inside the user directory, under user X, this is my regular user directory. This is what you expect. So if I go to user X and I do a directory, I see the exact same thing, and notice that it all matches, right? You have the 3D objects, contacts, etc. Right here, notice there is a hide me folder. So if I go to the users directory and I do a directory, notice the hide me folder is missing. That's hiding and denying access. If I suspect that it's there, I can try to go there. That's the concealment. This is the data cloak. Can't find, oops, can't find the file specified, but it's right here, and I can go inside it. And there's a document here called test that I can go and edit however I want. I can save it, open it up. It's still there, but I can't even go to it. What if I try to remove the directory? Can't find the file specified. Okay, well, what about the documents folders, right? There's usually stuff in a document folder. Now, in this case, on the regular user, there isn't. But here, I know, because I put it there, there are a bunch of documents in the document folder. So why don't I go to the document folder? Now, when I enumerate it, notice here I'm only seeing two things, a text file and a image, whereas here I actually have 6. Remember when I said that I was hiding Office documents? Look at the extensions of the files that are being hidden. PDFs, document files, so Word document, PowerPoint, and Excel spreadsheets. I can't see those. Okay, so what if I want to try to delete 4.1 update.pdf? Oops. Okay, this should delete. This should delete that file if I can have access to it. Even if I can't see it, I suspect it's there. Could not find. And yet it's right here. And I can open this, show it what it is. It's just an update for 4.1, which is an old update. And I might open it in Explorer or Windows Explorer. Yep. All right. So I'm going to close that. So that is the hiding and denying. So this is how you hide and deny access to local files, folders, data, etc. Now, one of the other interesting things that we do, remember as I showed you that deflect function and that redirection. What if we try, say I don't know what this 5.130 is, right? And remember, when I showed you the open ports, there is no SSH port open here. There's no port 22. What if I try to SSH to that? I connect. How did I connect? Notice the IP address is this Windows box, but it's showing with an SSH server. What if I try to log in with that stolen Brad Pitt account with a password that I stole? I get in. Notice it's a CentOS box according to this system, yet I know for a fact it is a Windows box because this is the IP address of the system I just connected to. That is inbound deflection. That's outbound deflection in action, right? Because this system is unprotected, and yet going outbound from this protected system, I'm getting redirected to a decoy. Now, what about web, right? Notice here that there is no web services running on 192.168.5.189. But what if I connect to it? How did I get this web service? This is a Swift web page. This is what you normally see in a bank if you're going and connecting to the Swift messaging service to transfer money between banks, right? But I know for a fact, because I just showed it to you, there is no port 80. This is redirection inbound. So I went to this system from an external system, from another system, and it redirected me because there was no port 80 that was open. It redirected me to a decoy web server. So that is deflection in action. Okay, so now let's go to the next piece. So now that we've deceived and misdirected the attacker, it is time to interact with them. And we do this by engaging attackers with decoy assets that we deployed in part 2. Remember that? Where we were deploying assets, and I said it was optional, but this is really one of the key ways for you to develop threat intelligence and collect forensics. There is some forensic collection that happens at the endpoint, but a lot of the information you're going to capture happens at the decoys. So this occurs in the enterprise network with decoys both on premises and in the cloud. The decoys mimic production assets for the attacker to attack. As they interact with these decoys, the deception environment records all of their activities. We can collect the forensic data from these decoy interactions and use that forensic collection to create or develop threat intelligence. Now, as I mentioned earlier, this forensic collection also happens at the endpoints where the solution tracks the attack activity and records the processes and commands. We can also conduct endpoint memory forensics to capture and pull any ephemeral data that gets loaded into memory during the attack. We can then extract indicators of compromise to threat hunt, and we can correlate events for analysis and develop threat intelligence from all the data that we've gathered. So let's see what this looks like. So I'm going to pull up the decoy. This is the bot sync. This is our dashboard. Now, prior to this was empty. I had completely emptied out. That's why there are only 11 activities showing. And all of these activities are what I just gathered in the last hour, right? When we started this, this webinar. So let's look at the events, type of events that we captured. So let me go ahead and refresh this real quick. So here's all of it. Now notice there was nothing until I refreshed it. This is all of the activity that we just did. Here is the file service discovery. Here's the enumeration of the files and directories, right? Let's expand that. So this was doing a directory enumeration locally on that endpoint. Here is the AD privileges. We were looking at some of the privilege groups that we detected. Here is that KList command that we ran. So we were looking, this is when we were looking for the Kerberos tickets and the SPN scans, right? So this is an SPN scan. Here is the network share discovery that we ran, where we were doing recon. So all this activity just happened. Here's some, all of this we just did. And this is all of the activity that happened on the endpoints. Now, remember when I mentioned that we can look and understand the processes that are doing all this? Here's the endpoint report. So notice here in the past hour, there was nothing. So let me go ahead and refresh it by changing it to month and back. So this is everything that just ran in the past hour. Notice the timestamps. So this is everything I just did. Here is the discovery, right? This is discovery information where I was looking for a PowerPoint, those hidden Office documents, right? Here's me trying to do a delete for this protected hide me folder, right? This is all of the data that we just captured in that 15, 20 minutes. Here's the netstat command that I ran to look to see what ports were open. Here's all of the SMB discovery when I was looking and did a net use command, right? All of this happened. Here's the pings that I ran. Here's the set SPN command that I ran, right? Here's me looking at the Brad Pitt user on the domain. All of those commands we captured. And so now you can take all this information. Not only do you understand what they're looking for, in this case, they're enumerating a bunch of stuff and it's clearly recon activity, but you can also, based on the tools that they ran, because here, this used the net command to run netexec. Here's the command.exe, which ran these commands. Now, if it was another process like Bloodhound, we would see bloodhound.exe, right? And here are all of the executables that ran and all of the functions that identified them and all the features that identified them, the type, the queries, everything. So this gives you a really good idea of what's happening at the endpoint. And so now you can take all this information, you can do your response activities, you can develop the threat intelligence, and everything here is at your fingertips. So besides the question that I'd answered, for you, this concludes the demonstrations, and hopefully you've learned a lot. You've got a lot to think about, and you've learned quite a little bit about what we do and how we do it. To learn more about the Threat Defend platform and all the various free trial offers, because we do have free trial offers that are going on right now to get assessments and things of that nature, please visit us at www.atibonetworks.com. Now, besides the question that I've already answered, are there any other questions? So the question we have here is that are attackers just going to start checking to see if Ativo or other deception tech is running? We assume that they already do. The critical part of this is that it's not the first thing they're going to try to look at. When they first get onto a system, most attackers are already going to be looking for those credentials that are on the endpoint. If they start looking for things like Ativo or other deception platforms, we actually do a very good job of hiding all of our assets. And just the mere fact of them trying to find and look for us is going to trigger an alert. It doesn't really matter if they do or don't. The fact is, in order to progress their attack, they're going to have to move forward and do stuff, some of these things that I've done to do reconnaissance on Active Directory, move laterally and escalate privileges and all of that. And they're going to have to do all that, find their targets and everything. And so any of those activities that touch a protected system or touch a decoy, we're going to detect, and you're going to get an early alert, because this is all happening and early during the reconnaissance. Does this work with other SOAR platforms or orchestrations? Yes, it does. We actually do have integrations with several different solutions. We do have many integration partners. Not only do we have integration partners, but we also have our own orchestration mechanisms. We run playbooks. We have playbooks that you can configure to automatically respond to an incident using any of the built-in integrations that we have. And so these are all of our current integrations. And notice here, there are some orchestration solutions. So yes, we do support, and I apologize for the blinking, we do support the several orchestrations. These are native integrations where we have they have our tiles as part of their workbook, and they can trigger it based on that. But we can also trigger any of these integrations that we have, either responding with a network block, or doing investigation and analysis, or responding with doing an endpoint quarantine, either natively or with any of those solutions that we have. So yes, we can share information with orchestration solutions to trigger their workbooks, or we can trigger our own. We do have a native quarantine function as well. Our deflection function can set it to automatically quarantine someone by limiting all inbound and outbound activity to only the decoy environment. And that way they can only talk to the decoys. So another question we have is it necessary to get a TiVo endpoint in the attacker and victim hosts to track the attack? No, not necessarily. You can, if you do have the TiVo endpoint solution in both the attacking system and the victim system, then you will be able to see all of that activity. But we do track based on where the attacker is going and the queries that they're running. Again, we're seeing the queries that are happening at the endpoints, so we can see where they're jumping to. But yes, if you do have the endpoint component on both the attacking system and the victim system, you can track the attack much more closely and identify how they're hopping between systems. And we do have a function within our BotSync solution that can show you how the attack is progressing based on where the alerts are coming from and how the attackers are moving from system to system within the environment. All right, are there any other questions? Is it possible for them to shield their activities from a TiVo? So you have to think about what the attacker is doing and how they can shield their activities, right? We are looking at a much lower level than they are when they're running the commands from the endpoints. So an Active Directory query has to go through either command line or PowerShell or anything like that, or even another application that uses those APIs like Bloodhound. We're looking for those things, right? As soon as they run that query, that command, we're going to see them. Now, is it possible? Probably there are certain things, like say they make custom binaries and you use only those, but most attackers do what's called living off the land, and they use what are called low bins, living off the land binaries. And living off the land is exactly that. You're using the existing tools within the environment to progress your attack, because the fewer things you upload, the more you limit your interaction to only what is built into the environment, the less likely you are going to get detected, right? If you upload a tool to an environment and an EDR solution notices this weird application is starting to do a bunch of things, then it's going to generate an alert, right? As an attacker, I don't want to do that. I want to work with only the things that are already found, because I can use all of these native tools that are already built into the environment to either run my queries or, in some cases, assemble malware that exists only in memory and then use that. So is it possible? Yes, but it's extremely difficult, because no matter what they're doing, they still have to use those binaries to access the APIs to talk to things like Active Directory. When they're trying to do port and service scans, right? Anytime a protected system either queries or gets an inbound request, like, or either does an outbound or gets an inbound request to a closed port, and even if it's one of the common ports like port 80, or DNS, web, SSH, FTP, If it's not open on that system, it's going to get deflected to a decoy, and the decoy is going to generate an alert and respond. So for example, in that deflection I showed you, I had a Windows box that I was talking to. It was not running a web service. There was no port 80. And yet when I queried port 80, when I touched it with a web server, even if I just did a port-to-port probe and tried to telnet to port 80 and did some banner grabbing, it would already generated an alert, right? So it's very extremely difficult. So what we're targeting is not their specific tools. It's not what they're using. It's what they're doing. It's the activities that they're doing that they have to do in order to progress the attack. So is it possible? Yes, but it's highly unlikely. If you have any further questions, or if you want more information, please reach out to us at www.ativonetworks.com. If you want to contact somebody, request a demo, the forms are there on the webpage. And I thank you for your attendance, and have a good day, everybody.